Hello everyone, welcome to Numeric Ninja. Today we are going to discuss a problem that is taken from AIME 2016. The problem is as follows. Let P of X be a non-zero polynomial such this condition over here is true for all real X and P of 2 whole square is equals to P of 3. Then if P of 7 by 2 is equals to M by N, then find the value of M plus N if M and N has GCD of 1. So basically here we need to find the value of P of 7 by 2. Now the first thing that strikes our mind is that this is a form of functional equation because a polynomial is apparently a functional itself. It's a function. A polynomial is a function. So we can treat it as a function. So in functional equation problem, we try to put some values and see what are the different values of the function at different points, or for a specific value, what are the points that gives out that certain value. The similar approach will be towards this problem also. So if we put x equals to 1 in this problem, we will get the left hand side as 0 times p of 2 is equals to 2 times p of 1. So we can say that p of 1 is basically 0. Similarly, if we put x equals to minus 2 in this equation, we will get the left-hand side as minus 3 times p of minus 1, and the right-hand side will be 0 because it's minus 2 plus 2 times p of minus 2, and this is 0, so the right-hand side will become 0. So from here, we can say that p of minus 1 should also be 0. Now, if we place x equals to 0, yes, if we place x equals to 0 in the above equation, we will get that the right-hand side over here is basically 2 times p of 0, and the left-hand side over here is basically minus 1 times p of 1. So we can say that minus 1 times p of 1 is equals to 2 times p of 0. And since p of 1 was already 0, we can say that 2p of 0 is also 0. So from here we can say that p of 0 is equals to 0. Now since p is a polynomial, we can say that by factor theorem, x minus 1 and x plus 1 are factors of p of x. Now since x minus 1 and x plus 1 are factors of p of x, we can write down p of x as x times x minus 1 times x plus 1 times q of x. Now since p is a polynomial and this over here is also a polynomial, we can say that q of x must be a polynomial also. Now let's go back to our original relation. Let's copy it down. Now let's here paste it. Now in this relation, if we put px as x times x minus 1 times x plus 1 times q of x, let's see what happens. The left hand side becomes x minus 1 times, you have to find the value of p of x plus 1, and p of x plus 1 is x plus 1 instead of x plus 1 minus 1 instead of x minus 1, x plus 1 instead of only x plus 1 times q of x plus 1. And this is same as x plus 2 times just simply p of x, that is x times x minus 1 times x plus 1 times q of x. Now when we simplify this, this becomes x minus 1 times x plus 1, and this will become x, and this here over here will become x plus 2 times q of x plus 1 is equals to x plus 2 times x minus 1 times x plus 1 times q of x. Now from here we can cancel x minus 1, x minus 1, x plus 1, x plus 1, x, and x plus 2, and x plus 2. So what is left is q of x plus 1 is equals to q of x. We could cancel these terms because we already know that We have already put x equals to -2 and x equals to 1 and -1. We know that p of x is in this form. So we just need to find relation between q polynomial. So from here, we can say that q of x must be a constant because we know that q of x is a polynomial, and a polynomial is only periodic if and only if it's a constant polynomial. So we can say that q of x is basically equals to some constant c. So we can say that p of x over here, that was their initial form, that is basically equals to c times x minus 1 times x plus 1. So we just need to find the value of c. So how we can find the value of c? We can find it by using this relation over here. So let's copy this relation over here. Let's go down and paste it. And let's copy down this form of the polynomial and paste it down over here. So combining these two, we get that basically p of 2 as c times 2 times 2 minus 1 times 2 plus 1, that is basically c times 2 times 1 times 3, that is 6 times c, and p of 3 becomes c times 3 minus 1 times 3 plus 1, that is basically c times 3 times 2 times 4, that is basically 24c. Now, since p of 2 square is equals to p of 3, we can say that 6 times c whole square is equals to 24c. That is basically 36c square is equals to 24c. So if we divide both sides by 12, we get 3c square as 2c. Now, c can either be 0 or it can be 2 over 3. Now, if c is 0, the polynomial become constant. If c is equals to 0, it becomes 0. The polynomial p of x will become 0. And if c equals 2 by 3, then the polynomial here becomes 2 by 3 times x minus 1 times x plus 1. Now, let's see what we needed to find. I needed to find the value of p of 7 by 2. So from here, we can say that p of 7 by 2 is basically 2 by 3 times 7 by 2 times 7 by 2 minus 1 times 7 by 2 plus 1. So this is basically nothing but, let's simplify it. It's 2 by 3 into 7 by 2 times 5 by 2 times 9 by 2. So this 2 and this 2 gets cancelled out. This 3, 9, and this 3 gets cancelled out. And the numerator over here becomes 21 times 5 by 4. And 21 times 5 is basically 105 by 4. And these, since these terms is the numerator and the denominator has no common factor, so we can say that basically m is equals to, I think the m was written in the numerator. Yes, m was written in the numerator. M is equals to 105 and n is equals to 4. So the answer, that is m plus n over here, is equals to 109. So hence the answer to this problem over here is 109. I hope that you enjoyed the video. If you did give it a thumbs up. Please like, share, and subscribe to my channel. See you in the next video.